I'm going to give you a brief introduction to the company and how we see the SD-WAN market. Then we're going to follow up that with Damon Ennis, our SVP of Products, taking you through the product line in more detail. And then finally, we're going to have Rolf, one of our product managers, walk you through with a live demo of some of the capabilities that we are delivering with EdgeConnect today. So, what is the WAN all about? And I know you guys are experts, but for people that are watching, I think it's sometimes a good idea to boil things down to what really simple terms. And the WAN is about connecting users to applications. And for 20 or 30 years, we've been doing that essentially the same way and presenting all of the complexity that happens underneath that way too far up the stack, so way too many people have to understand all about how networking works. And really, I think that software-defined networking is about pausing and rethinking things, looking at what things we can reuse, what things can we do differently, so that we can connect users to apps much more easily and much more efficiently and much more cost-effectively. What we want to be able to do is deliver users their application with quality over whatever kind of connectivity they want, and being able to find the mix of connectivity that at any point of time meets their application requirements. So that's about SD-WAN. So how do we get here? Who's Silver Peak and where do we come from? So I started the company in 2004. We focused on WAN optimization, and in particular WAN optimization that scaled to really high bit rates, scaled to really high packet per second, scaled to lots of flows and lots of sites. And we pursued that market. We created what people think of as the data center WAN optimization market, helping a lot of the biggest companies in the world move their data around the globe. And from there, we learned a lot about how to deliver performance, networking performance in software. So right from the beginning, our WAN optimization products were running on Intel x86 64-bit Linux systems. So essentially from day one, we've been a software company and specialized in driving performance out of software running on standard Intel hardware. In 2011, we realized that rather than shipping that software pre-installed on white box hardware, we could actually deliver it as VMs and have a software delivery model. And so we built a second competence inside the company to complement the WAN optimization competence that we had. And that competence was around virtualization. So we learned how to support the whole cross-section of hypervisors from Hyper-V, VMware, KVM, Zen. We learn about the management and orchestration ecosystems that exist around those hypervisors. So VMware, vSphere, and Microsoft System Center and the OpenStack project. And from that perspective, we began to realize that some of the things that were going on inside the data center as the data center became the software-defined data center, as people looked at SDN, some of those concepts didn't need to be confined to the data center. Some of those could also be applicable in the wide area network. At the same time, we had customers telling us that it's great that you optimize all these applications that are flowing between my branches and the data center, but I'm moving a lot of those applications to the cloud. And so what can you do to help me as I move my business to the cloud? So there's SDN, there's cloud. And then the other thing that we heard from customers is a lot of my traffic is going to the cloud. I've got these internet links I'm using as backup to my MPLS. Is there some way I can more effectively use those internet links? And can I figure out what the best way to get to my SaaS application is? Those were questions we were being asked in that 2012, 2013 timeframe. And so we realized that there was a big opportunity for the company to move beyond WAN optimization and look at how we address the wide area network in general. How do we build a better WAN? So as we talked about, it's all about connecting users to applications. And we see that there's two important, and these aren't the only two important technologies, but two important technologies associated with building a WAN. One is WAN optimization, which is where we've started and where we're coming from. And then this new market, SD-WAN. WAN optimization is all about improving performance over distance. It's applicable for anyone that's got geographically dispersed locations, because as latency goes up, the distance, it's related to the distance between locations, that affects application performance. Now, on the other hand, SD-WAN is all about connecting branches cost-effectively and rapidly. And so it applies to any enterprise that has a lot of locations. And so we see that there's an overlap between these two markets. Basically, anyone that has geographically dispersed locations that they want to connect rapidly and cost-effectively. And so at Silver Peak, we have two main product lines. Our classic product line, the NX and VX product family, which are targeted at the WAN optimization challenge. And then earlier in 2015, we introduced the Edge Connect product family, which is what we're going to talk about today. It's focused on SD-WAN, and it solves the pure SD-WAN problem. It also we have the ability to optionally add what we call boost, basically WAN optimization on demand, so that you can address the intersection of the two markets, so people that want both things. In terms of what's unique about Silver Peak, I think you'll see today there's a lot of interesting stuff we're doing. But at the highest level, the one easiest thing to understand is that we're really the only company that with one software base, with one set of products, can cover WAN optimization in a pure sense, SD-WAN in a pure sense, and the intersection between those two. So, looking out there today, most people use MPLS for their wide area connectivity. They like it because it's predictable, it comes with an SLA, it's relatively reliable, it's private, so you're not sitting on the raw internet subject to DDoS attacks or whatever. The bad is that it's relatively expensive, it's relatively slow to do add moves and changes, and it's not really well set up if your apps are in the cloud versus in the data center. If we kind of actually rewind a few decades and look at how we ended up with MPLS, back when I started in networking in the very late 80s, early 90s, most WANs were built with private lines. And the private line or leased lines were a great way of getting point-to-point connectivity. However, if you had lots of branches, every time you added a new branch, you had to make changes at the head end to bring those new circuits in. And so people came up with the idea of frame relay as a way of virtualizing that connectivity out to the branch. They're called virtual circuits. And that revolutionized the WAN. And within probably 5 short years, the WAN changed from being pretty much all private line to being pretty much all frame relay. And then frame relay dominated networking wide area networking during the 90s. And then towards the end of the 90s, people were looking at, okay, I've got voice over IP I want to roll out. Quality of service is important. I don't want to be bringing everything back to a hub. I want to get really simple mesh connectivity. And so they released, so that's basically where MPLS came from. It was an easy way to connect branches and get mesh connectivity with quality of service. But it's been that way for 15 years now. So since 2000, between 2000 and 2005, frame relay went away. MPLS became the dominant technology. What's happened now, as we've said, is that those apps are more and more moving to the cloud. So if you're using MPLS, often that traffic that's going to the cloud is being backhauled from the branch to the data center, and then from the data center out to the cloud, and then from the cloud back to the data center, and then back to the branch. So it's kind of taking a circuitous route. And for many people, it's, why can't you use the internet to get to those apps? Why do we have to backhaul via MPLS? It's a situation where there's a technology which has been doing a great job for 10 or 15 years, and now the problems have changed. We need to look at how do we adjust. And it doesn't mean throwing away MPLS. In fact, if you look at what SD-WAN's about, it's not really about replacing MPLS or replacing the internet. It's providing an overlay over whatever underlying technology you want to use for your connectivity, be it MPLS or combinations of internet connectivity, and making that overlay really easy to manage and deploy. So why aren't people leveraging the internet more today? When you talk to customers, they give you a few reasons. The first is they're worried about performance and they're worried about the reliability of the internet. So if I'm using a cable internet connectivity, there's maybe no SLA. Who do I call when things aren't working? Versus with MPLS, I get an SLA. The second thing that concerns them is security. So if I'm on the internet, how do I make sure that I'm not opening up myself to attacks and creating more problems than I'm solving? And then finally, they're worried about visibility and control. So is there, when people want to be able to just do something with their cloud traffic, they may want to have their SaaS applications go one way, but they may want to take other internet-bound traffic and look at it more carefully before they let it get out of their network. And so in order to deal with internet traffic, they want to be able to subdivide internet traffic into different categories. So you've got to have visibility into internet traffic. You can't lump all HTTP together. And then you've got to be able to control subsets of that traffic and apply different rules to different kinds of internet-bound traffic. And without that capability today, it really limits what they want to do with the internet. So as a thought experiment 2 or 3 years ago when we were at the outset of our SD-WAN development program, we asked ourselves a few simple questions. What if we could build a product that would let you use the internet to save bandwidth costs, to reduce your bandwidth costs by as much as 90%. So if you look at, say, MPLS costs in San Francisco, according to one survey, people that track this stuff for a living, the median price for a 10 megabit MPLS circuit in San Francisco is about $2,000 a month. You could buy 100 megabit per second internet connectivity for perhaps $100 a month. So you're talking about more than a 10 times gap in bandwidth and about a 10 times gap in price. And so there's a real opportunity there if you can leverage the internet to save a lot of money. The second thing is, what if it was easy to be able to switch carriers? A lot of people feel like they're really locked into their MPLS provider, and even when they come up for negotiation every 3 years or whatever it may be, it's kind of not a real negotiation because the switching costs are so high. What if we could make it so that it was really easy to deploy a new branch, so that you could deploy a branch in minutes rather than months? What if anywhere you could Skype from, you could build a branch? You just plug in, get a dynamic DHCP address, even if it's behind NAT, if you could use that broadband IP to build your branch. And then what if, even though you're using the internet, you could deliver private line-like performance? And so those were the goals that we had when we started thinking about how we would build EdgeConnect. So what is EdgeConnect? It's a solution, and it's got 3 pieces. The first piece is the EdgeConnects themselves. These are hardware devices that go out in the branch, and there's a virtual form factor as well if you want to run it on any standard Intel system. Damon's going to go into a lot more detail on EdgeConnect. Basically, you plug it in, plug in power, plug in networking. It's zero touch there. Basically, phones back home, associate itself with the customer's orchestrator, and from there, the customer can accept that device onto their network, and it will be automatically provisioned. The second piece is the orchestrator. And so this is the central controller for the network. It makes sure that the devices are all maintained in a known good configuration. It builds the mesh of tunnels that comprise the overlay for the devices to send traffic across. And it's also where the IT administrator goes to describe their business intent policy that they want to follow in the network, and where they can get a lot of their visibility and reporting. The third component is Unity Boost, and this is what I was talking about before. It's basically WAN optimization by the drip. You buy it by the megabit and deploy it when and where you need it. So a customer could buy 500 megabits of WAN optimization for their network. They can deploy that wherever they want. They can move it around as long as the sum total of the WAN optimization in the network is less than 500 megabits per second. So last slide here, and I know you guys are technical, so I apologize that I'm starting out with this with the marketing pitch, but I want to set people, get people framed with who Silver Peak is and what we do. And real shortly, I'm going to pass it over to Damon and Rolf, who will dive down into the details and tell it like it is. If I was just to, in one slide, talk about what's the value of our EdgeConnect solution to the customer. First is flexibility. We let them choose whatever connectivity they want, a mixture of MPLS, of cable, of DSL, of 4G LTE wireless, whatever they want in any mix in any branch. The second thing we do is give them visibility and control. So the ability to understand what apps are going across their network, and the ability to get visibility into how is their network performing, how is each path performing on a second-by-second basis from the point of view of latency, jitter, and loss. The third thing is performance. We deliver performance at the base level for SD-WAN, basically making those internet links work like private lines. And we're going to talk in detail about some of the magic that goes on there. How you take two medium quality internet links and make that perform like a private line. On top of that base level of SD-WAN performance, we have Boost. So we have the ability to bring the WAN portfolio to the table, doing latency mitigation, deduplication, and so on. The final set of benefits are around savings. Delivering savings to customers, first off in terms of bandwidth savings, but secondly in terms of operational savings. It's much easier to build and manage an SD-WAN than it is a traditional WAN. And then finally, there's potentially savings with CapEx, because the way we see the WAN evolving is today most branches are relatively heavy. They have Cisco ISRs or other routers, and there's a lot of functionality being dragged into that router. It's a Swiss Army knife. In the future with SD-WAN, we see that there's an opportunity to build a much thinner branch where the only device there is an SD-WAN edge and perhaps a few Wi-Fi access points. But there's potentially a dramatic reduction in CapEx as well. So savings in three areas there. Okay, so that's the overview of Silver Peak. And I'll pause here in case there's kind of high-level questions about Silver Peak, where we came from, and where we're going.
You're still building off your WAN background, that WAN acceleration background. That's, to my mind, that's what sets you apart from other SD-WAN vendors.
Yes, yeah. So we have a common software base spanning the classic WAN optimization products all the way through to SD-WAN. And I think one of the reasons why we've been able to do this is right from the outset, right from 1.0 back in 2005, we were an overlay-based system. So a lot of the other WAN optimization technology kind of started with a TC proxy as the base. We decided at the beginning we wanted to be able to optimize all apps, not just TCP. And so we designed the system as an overlay with GRE, UDP, or IPsec tunnels. So we're the central orchestrator. And so that's kind of, I'm not saying that we invented SD-WAN in 2005, but we kind of started out with a framework that maps fairly cleanly to SD-WAN today. And so that's why we've been able to be consistent in a way that we've been able to use software over the years and develop on top of one base.
Are there many customers telling you that these devices are all Ethernet? Are customers really at the point where Ethernet is enough to connect to the WAN, or do we still need the legacy interfaces of old?
Yeah, that's a good question. So you're right. All of our devices are Ethernet in and Ethernet out. And so there's kind of a prerequisite there that the WAN connectivity that we're getting is passed to us on an Ethernet interface. And for most customers, I think that's enough. We do get people asking, well, what about a TDM, T1 interface or whatever? And I think that although that requirement exists today, you'd probably be shooting behind the duck if you were developing hardware for that case, especially as people move to broadband. It's like the intersection between people that want to get more bandwidth by using the internet, by getting 10 or 100 megabit increments, and they still want TDM connectivity. It's there today, but I think it's going to go away over time.
They've probably got, if they're using legacy TDM like a T1E1, they've probably got a legacy router.
Yes.
You can just wind it back to something dumber and just move the intelligence out of the router into your box,
Yeah.
I guess.
Yes, yeah, that is what we see. So in cases where they have that connectivity, they can leave their legacy router in place and essentially
through there and then round to the right.
it's doing a little bit more than converting the format, but basically it's there as a conversion box.
Thanks.